Hello, good people. Welcome to the next video here. And this is the last section of this 1.5. And that is, we see many types of piecewise functions, but this one is a particular special case of a piecewise function. And it comes in the form of this equation. So the function f of x equals the absolute value of x divided by x. Now, I could sit here and explain, like, how do we get the graph that we do, but to save time, I'm just going to graph it and show you what it looks like. If you think about it, the numbers on top are always going to be positive. Whatever value I substitute on top would always be positive. Whatever value I substitute on the bottom could be positive or negative, right? And so because of that relationship, here's my example. I'm going to maybe zoom in. Let me do a zoom 4. This is what we see. It's a piecewise function made up of two constants. One of them is at -1, one of them is at +1. On the left side, maybe I should do it this way. On the left side of the y-axis, I'm at -1. On the right side of the y-axis, I'm at +1. But what happens at x equals 0? Well, there is no value. If I press trace, you'll notice at the bottom, and I'll try to move this out of the way here, you'll notice at the bottom, when x equals 0, there is no y value. But when x equals 2, oh yeah. Or when x equals negative, let's not do -6, -1. So it's always, the answer is the y output, the y value is always going to be either -1 or +1. Okay, so let's make a sketch of that on here. I'm going to put a little tick mark at -1. I'm going to put a little tick mark at +1. And we said the graph is going to look like this. But when I get to the y-axis where x equals 0, there is no point there. There is no point here. This is the graph of the special case, absolute value of x divided by x. So then if you remember your transformations, you can make drawings of these functions in example 3, right? So if you recall, whenever we subtract a number from x, it's going to shift it left or right. Well, in this case, we're subtracting 2. It's going to shift it to the right. If you don't believe, then let's see. I'm going to turn this off. I've already pre-entered these. And does it move everything to the right? Yes, it moves everything to the right 2 spaces. So my drawing would look something like this. 1, 2, still at -1, still at +1, but now it's going to look like this. And there's an open hole, and then up here, and this is what the graph looks like. All I did was it shifted the graph that we originally drew to the right 2 spaces. If that's the case, actually, let me write that on the paper here. So this shifted right. If that's true, what's happening on letter B? Well, now I'm adding 4 instead of subtracting 2, so it's going to shift. Where is it going to shift? What direction? To the left. But it's also going to make the y values 3 times as big. So there's a vertical stretch by a factor of 3. All the y values are going to get 3 times as tall away from the x-axis. Let's see what that looks like. I'm going to come back over here. Let's turn off example 2 and let's do example 3. We did move to the left, 1, 2, 3, 4, 4 spaces, and notice it got stretched away from the x-axis by a factor of 3, meaning instead of being at -1 and +1, now it's at -3, +3. So I come over here and we'll make a little sketch. Let's put a tick mark, 1, 2, 3, -4. But this time, 1, 2, 3, and 1, 2, -3. So my graph will look like, and then up here, something like that. What about letter C? What transformation do you think is happening? Because letter C is set up differently, right? What do you think is happening? Think about it for a little bit. Which transformation do you think is going on there? If you guess that it's shifting to the right, you are correct. It is shifting to the right. But it's not a vertical stretch because that 4, I'm not multiplying by 4, I'm dividing by 4. So this turns out to be a vertical compression. What does that mean? That means that those two lines that we see, sorry, I'm trying to get into the picture here, those two lines are going to get compressed and the y values are going to be 1/4 as much. Well, let's see. Is that really what happens? Or am I just making stuff up? Graph. It did shift to the right 3 spaces. And if you look carefully, the y values are not -1 and 1 anymore. They're -1/4, +1/4. So what we thought was going to happen, or what we talked could happen, did happen. So 1, 2, 3. But now it's at -1/4 and +1/4. Where did the 1/4 come from? Because right here, this is 1/4. Whereas over here, this was 3/1. That's a stretch. 1/4 is a compression, right? And then we can finish the graph and be on our way. Okay, so the whole idea here is we need you to memorize what this graph looks like, because if you can make a quick drawing, you can figure out the limit fairly easily. So here's an actual AP exam problem. Find the limit as x approaches 3 from the left side of the function absolute value of x minus 3 over x minus 3. I'm going to let you do that. Figure out which one you think it is, bring it to class, and we'll talk about it then. This is a very special case of piecewise function where it's the absolute value of x over x and all of its transformations. We know that what it's going to look like. We can predict what it's going to look like, and you can get that answer fairly quickly.